This is part 2 of Chapter 9 lecture on air. So we ended last lecture talking about what are the pollutants in the troposphere that are affect humans and ecosystems. Remember, the troposphere is that thickest layer closest to the Earth's surface, and it is, you know, the most important pollutants that can affect humans and the ecosystems. And that here is acid deposition, heavy metal pollution, and smog. Here's just a good example of acid rain. So in Athens, you can see the noses of a lot of these figures have been worn off. You can see here, and this is all by acid rain. Here's another good image of acid deposition in the death of these trees in Tennessee. Here, this actual map shows you the most acidic areas in the United States. And if you look here, these are the highest areas of acidity. And if you ask yourself, let me look at this map and figure out why. Why are these areas the most acidic? You can say to yourself with pH levels that are 4.5 to 4.7. Remember, if you ever have seen a pH scale, right, that goes from 0 to 14, and you'll see from 0 to 7, you'll see those areas are acidic, and then you have 0, right? And then 0 means neutral, and then you have your bases. So you'll see that the most acidic areas are these areas that are closest to the most industry. So where there's the most industry, you'll see the most acid deposition. Look, North Jersey. You'll see the most acid, and this is because this is where the most SO2 and NOx are emitted. But the other thing is these are the most acidic areas, but don't forget, acid rain all the pollution from here can go up in the atmosphere and then maybe pollute Canada. And that has happened in the past. Let me just quickly browse here real quick, and I want to just show you if I can do this real quick. Acid baseline. I want to just quickly show you if I look images for your images. Let's just quickly here. You can see here your pH scale. I like to show your pH scale. So your pH scale is here. Whoops, and I want to just make this a little larger while I'm talking to you. Woo! No, where did you go? I don't want to look up an acid-base tutorial. But if you look here, the acid-base scale, pH acid-base scale, you can see here that the acids are on the one side, and then the bases are over here, and this is neutral. So you have your acids and your bases, and then this is the neutral line. So if you're ever wondering about acid and bases, there you go. I'm going to move this a little back over this way so we could talk about it. Okay? And you can see here, so what happens is this is where the pollution comes from. Here it is. It emits the pollution. The pollution then is condensated in the atmosphere, and then it rains. And so this is a big problem. So usually the acid deposition is not just right where the pollution is. It blows. Remember those dispersion and deposition? Where does air pollution travel to? It deals with the height of the emission, the wind direction, as well as the wet and dry deposition. Remember that. Those things play a role in where maybe the acid will land. This is showing you VOCs in large cities such as Hong Kong. You know, photochemical smog is common, and we talked about this because of that, because of the pollution in the atmosphere. Now, we just talked about pollution that's ground level. That means in the troposphere. What about pollution that's high up in the stratosphere, which is the next level above the troposphere? And that is no direct effect to human health, but it can influence climate. So aerosols can cool the Earth's climate. And then this is, of course, where damage to the ozone layer occurs. So, or the greenhouse effect, well, actually the greenhouse effect affects closer to the ground. But this is really where you have to be careful, and the ozone layer is one of the biggest issues here in the stratosphere, because that ozone goes up into the atmosphere, and then that is where the sunlight hits it, and that chemical reaction happens, and then the secondary pollution occurs, which is ozone. There's smog level ozone, and then there's the CFCs that break down the ozone layer in that stratosphere. And this is just the chemical reaction that happens. Ultraviolet light from the sun causes chlorine atoms to separate. So CFCs are the biggest issue in the stratosphere. These CFCs that are in aerosols or in other, a lot of times in refrigerants, a lot of times in anything that we spray from an aerosol can, they produce CFCs. And what happens is these CFCs go up into the upper level atmosphere, the sunlight hits it, a chemical reaction occurs, and then this chlorine atom, remember, because chlorine has one atom in its outer shell, it needs to attract to something, and once it bonds with something, it's very hard to break that. And so what happens is the chlorine atom then bonds with the oxygen, and it creates this ozone. Now these are images of the ozone layer hole. Hopefully you've heard about the ozone layer hole. This was 1980. You could see the hole got bigger, it got bigger, and now it's starting to get a little bit smaller again. It's monitored each year by satellite, and but although CFC emissions have declined significant, the long resistant time of these chemicals means that the hole, it has diminished just a little bit, but it hasn't diminished enormous amounts in size. The reason for this is it takes a long time for these CFCs to travel, these chlorofluorocarbons, to travel to the poles. A lot of times they travel to the poles, and it takes a long time for that to happen, and then that's where a lot of the destruction happens. But here's a couple things. In 1980, these guys won the Nobel Peace Prize in 1995, but Frank Sherwood, Roland, and Mario Molina, they began an intensive study, and these are the first guys to notice that hole in the ozone layer. They found that CFCs degrade that UV, that they, by UV release chlorine, and the chlorine in the stratosphere destroys the ozone, and that ozone we need the ozone in the upper level. Now down low we don't need that ozone, but in the upper level we need that ozone, because that ozone protects us from UV light coming into the troposphere that harms us, right? Creates skin cancer. Remember, if you look here, that chlorine atom in the chlorofluorocarbons wants an atom, and what happens is it binds with one of the oxygen atoms of the O3 ozone, and then that means that now that O3 doesn't exist anymore. So it attracts an oxygen molecule that breaks away from the O3, it binds with the chlorine, and it creates a new element in the atmosphere, but it also degrades the oxygen. It degrades that O3. So now we don't have as many O3 bonded molecules in the atmosphere, which means we don't have as much ozone in the upper level. We need a lot of ozone up there to block that UV radiation from coming in. So these three guys, they figured out that it was being destroyed, and they were able to find over the Antarctic that hole in the ozone layer. And what happened was they created what we call the Montreal Protocol. And the Montreal Protocol was, most developed countries signed it in 1980. And what they did was they signed this Montreal Protocol. The Montreal Protocol prohibited the use of CFCs in developed countries. Now that means that all your refrigerants a lot of times are taken away by companies. You pay a little bit of an extra charge. If you notice on a lot of cans, you'll see an X through CFCs on it, any of your aerosol products, and you'll start to see this, and that's because we banned that. Now, it doesn't mean developed countries still don't use CFCs. It doesn't mean that people don't illegally throw away their refrigerators, but overall, we have declined CFC use. Now, we have this big lag time. Remember that the CFCs that were in the atmosphere maybe in 1995 are still in the atmosphere, and we need to get rid of them. So it's going to take a long time for this repair to happen, but eventually we'll start to see the ozone layer repair. The issue is that if developed countries keep using, as their populations grow, keep using CFCs, then we're going to see a huge destruction in the atmosphere still, in the ozone layer. So just in summary real quick before we move to indoor air pollution is the fact that the ozone layer protects us from UV radiation. It's actually ozone in the upper atmosphere. Remember, ozone in the troposphere is bad because it's considered smog, but ozone in the upper atmosphere is good. It's being destroyed by chlorofluorocarbons because of chemical reactions. And what happens is then it forms this hole in the ozone layer. Once that happens, though, is that we've tried to repair it through the Montreal Protocol, but, because of the lag times of chlorofluorocarbons staying in the atmosphere, in the stratosphere, we haven't seen the rewards that we want to see. But eventually, if we phase out CFCs, we'll start to see a repair in the ozone layer. The next topic I want to talk about is indoor air pollution. And a lot of people say indoor air pollution is more hazardous than outdoor air pollution. It's definitely more polluted because it's trapped within your home or your workplace. And it comes from carbon monoxide, nitrogen and sulfur oxide, and VOCs. VOCs are a big deal, also particulate matter. Remember, any of the products that you use, all of the chemicals that you use in your house, all of those Clorox wipes, all of your Swiffers, all of those things that you have burning in your home, candles, all of that is indoor air pollution. And so it's really important that you limit the amount of sprays that you use in your home, whether that's perfume, whether that's hairspray, whether it's all of those Bath and Body Works things that you plug in your wall. All of those emit indoor air pollution, VOCs, into your atmosphere, and you're constantly breathing them. Also, indoor smoking. Really, if you smoke, I'm not going to give you a lecture on smoking because everyone knows it's bad for you. But if you smoke, it would be best for you and your family to smoke outdoors. If you could go sit on your front porch or sit outside on your steps or walk outside and just smoke. It's better to smoke outdoor. Yes, the United States have seen a huge decrease in smoking over the years, but you can see here in Africa and in a lot of parts of Europe, you'll start to see that smoke in China, especially in India as well. You'll see that a lot of people smoke. And this is a big deal because it creates a lot of indoor air pollution. This is just showing you places that have had a ban. Now this was from 2010 and this has been completely updated. So I'm going to skip this slide for now because it's probably an obsolete slide. So also indoor air pollution, construction materials. Don't forget all the VOCs from paints, adhesive, synthetic fabrics, wood preservatives, all of this stuff. When you buy furniture, sometimes it smells. All of that is VOCs. There's also asbestos, and we're going to talk heavily about both asbestos and lead because in Pennsylvania this is a big deal. Asbestos is a fibrous material that was used for insulation. A lot of times you might have asbestos material on the outside of your house or your pipes are wrapped in asbestos. And if you've ever touched asbestos fiberglass material, you'll get itchy. When I was little, the Pink Panther used to be the advertising source for insulation in your attics, and you would roll out this insulation, this pink insulation, and inside when you would touch it, you would get real itchy. Well, that's because there's little pieces of glass in it, fiberglass. And what happens is when you breathe that material in, those little shards of glass get stuck in your lungs. And when you cough or do other things, those pieces of glass rub up and down in your lungs, and that's what we call mesothelioma. Mesothelioma is a deadly disease. It has killed lots of people throughout the United States and other countries. Now, asbestos has been outlawed. It doesn't mean it's not still used, but it's been outlawed. Whenever someone does construction in your house and they find asbestos wrapped pipes or something like that, you need to make sure you have a mask on and it's properly handled. Do not try and do it yourself because once you break open those asbestos, the wrapping around the pipes or on your house, you then spread that asbestos and it's in the air and then other people breathe it in. So it's really important. It was banned in 1973. Okay, and it's really important. So I'm going to stop here in part 2 of the lecture, and then I'm going to continue on in part 3.